So we'll go ahead and start, and I know that a couple of people might trickle in, and that's totally fine. You came back! Yay! Thank you for coming back. I'm glad that you're here. We didn't quite finish doing the whole task today, so we're going to wrap it up at the end, and then we're going to talk about engagement for a minute, and then we'll go into how a task flows, like what out of what we did is normal and would be in most every 3-act task, and I'll give you some resources for that. And then if we have time, hopefully we'll talk about where you can find and pick one and how do you get ready for one. I'm willing to meet with you again if we don't get through all of that at any point that's convenient for you. So we'll accomplish as much of that as we can, okay? So we're gonna jump back, welcome, we're gonna jump back to the task, and I'm going straight to there would have been a little more like connection, but we're gonna go straight into the sharing part. Here are two actually. So this is a feature of Desmos that I can take a snapshot of somebody's work. And so we're going to take a look at Teresa's work. And hold on.
I already think I'm wrong.
All right. All right, so I know this is hard. I don't know if, Van, you're not going to be able to see it. Sorry about that, man. So Teresa, tell us what you're thinking.
Yeah, sorry. That's what I was trying for. But I think I'm wrong, guys. So we were talking after fourth go left yesterday, and we decided that Zoolander is only one person, not all of the people. Originally I was trying to come up with all of the different outfit combos. And so because Zoolander is just the man in the tux or suit or whatever, my whole mindset changed. So I don't know. I came up with 12 outfits, and then I was collaborating with Lori and I don't know, everybody else that was here, Caitlin, and they said, but wait, Teresa, you have to be able to swip swap. So like if you guys see where it says like ZRZ, then they could really be, no, but ZZR is on there. So I don't agree with this. I really think it's 13, not 25.
Okay, so let's look at one more and see who this person agrees with.
Hold on, Jordan might have a because.
Okay.
When it's flip-flop, are you talking about the ZRZ and then the ZZR?
Yeah.
Well, in the middle one, say that like the ZRZ, like the R is for like the middle.
Right.
Like the shirt. But then at the bottom, it's for the shoes. So those are different.
Right, but I have, do you see on the left side, I have ZRZ and ZZR up there. Wouldn't that be both of those two combos? And I wouldn't have to multiply it.
Which ones are you talking about?
Oh my God.
Sorry.
It's okay. I apologize. These ones right here.
Yeah, they're different because these are Z shoes.
Right, but if I just count, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Oh.
Wow.
Sorry.
So,
I now see what you're saying.
But no, that's still 12, not 13. Maybe just 12.
so
Maybe I agree with Van.
for the sake of time, I'm going to move a lot faster than I would in the classroom, but let's look at one other person that might help us, might change our mind. I don't know. Let's see. This is Lori's work, and it is upside down, but we are going to totally not worry about that. Okay, so we just flip it in your mind. Okay. All right, Lori, can you tell us what you've got? Oh, awesome.
Yeah, sorry, I didn't show again. So basically, I wanted to do a tree. What is it called?
I call it a ladder diagram.
Okay, I call it a tree. I don't know if it's right or wrong. But the way that I thought about it is that, and I kind of changed it here because I put zoo at the top, because I was thinking if I was doing all the people, I would do this once and then multiply it by 5. I don't know if that's right, but that would be the total. But thinking about zoo, and then he would have a red, a green, a black, whatever color, whatever those colors are. And then off of that is all the pants combinations. So then it would total 25, I think.
Can you tell us where you see 25 in that tree diagram that you created? Tree diagram? At the bottom? Be more specific.
It's all the lines of the combinations at the bottom, 5, 10, 15, 20.
Okay. I'm juggling way too many pieces of
There's
technology.
5 different outfits
Okay,
for-
hold on.
5 different outfits for each of the shirts. There's 5 different pant combinations for each of the shirts.
Okay. So let's see if somebody who didn't use a tree diagram could tell us what, for example, imagine it flipped. What is this to this to this? What could that represent, for example? Jordan?
One combination.
One combination. So this is supposed to mean like Zoolander, right here. Zoolander head. Then this means
Shirt color,
like a green shirt color, and then this one might be
all the pant colors.
yeah, all the different pants. So this might be like green pants, and then going all the way around. Cool. Okay. What do you think, Teresa?
No, I don't know. Maybe Lori's right. Sorry, I'm a follower, not a leader.
I did notice you had an equation on yours.
Yeah.
I did.
I
So
didn't know where those numbers came from, and it equaled 25.
you're right. It did.
She's like, you're right. I just didn't know, because if we had more time, I was going to ask you where
So
did you
the
get
12,
the
the 12
equation?
times 2 plus 1 originated from, I had 12 combinations and I times it by 2 because I could swap the tops and bottoms. Does that make sense?
Oh.
And then the plus 1 came from Zoolander and his original outfit.
I can buy that.
Okay.
Yeah.
What? No,
I know, that makes sense. That was my original logic.
Yeah.
And that's where, because at first, I think Lori and I were talking, we were like, oh, 24, 24. And I was like, wait, no, 25 because Zoo can be in his original outfit.
Awesome. This.
But I'm really confused too.
Okay. So we would in a classroom we would belabor it longer and it would be fantastic. But let's go ahead and for the reveal. So we'll start on that part. So I'm going to just to save us some time. I'm going to show us up here. Woo! So were you able to see it? It is.
I think I'm about to.
Okay. Whoa, it was 25. Okay. So in a normal classroom, I'd probably watch it again and have somebody try to narrate what was happening, kind of like matching that with somebody's representation that they did. Okay. Any final thoughts?
I have a question.
Yeah.
I feel like there should be like an easy way to plug numbers into some sort of equation to get that number.
Anybody know it?
Clearly not.
Isn't it just your options, like you multiply your options together?
3 sections.
Like your 5 tops times your 5 bottoms?
No, I didn't put a pineapple.
Yeah.
But
Yeah. So
If you have ice cream scoops, like 5 different flavors and 5 different toppings, the total combinations would be the 5 toppings times the 5 flavors.
yep, that's exactly it. And that's like exactly where we would want to go as a class. Like that's a perfect student or teacher move is like, is there something we can generalize out of this? You know, is there some sort of pattern? It's not just about like this one particular problem in 5 pants and 5 shirts. Like and that's I think it's called the fundamental counting principle. I think what we're trying to get at is this like there's a rule to how you can take all your options and multiply them together. So you did it. It changes if like you can't repeat something. You know, it'd be different like if he can't ever wear red and red or something together. That would be a different algorithm. But yeah, you've got it. Multiplying the 2 combinations together. And that'll work for any number of combinations that you had. I probably, as a teacher, wouldn't have just handed it to you that easily, but I'm glad you asked. Okay. Yeah. All right, cool. So moving back to here, we just have to talk for just a second about engagement. And I captured this moment yesterday.
you tweeted it?
I did tweet it, yeah. Hold on, I gotta get it.
Can I ask a quick question?
Yeah. Go ahead.
So would you go back to, because one thing I'm like thinking, would you go back to their original like high, low, middle? Because I know in my head, doing it just in my head, I couldn't do it. I was like wasn't making sense of it, and my numbers were all over the place. But then to be able to do it on paper, it made more sense to me.
Mm-hmm.
So would you go back with your students at all, or like how would that conversation go about? I don't know.
So her question was, would you go back and talk about the estimate that you did? And I would say certainly that could be a really cool thing to do as part of Act 3 is to revisit that and say, hey, did our final answer at least fall in between our low and high, you know, and that kind of justifies that or verifies that you were making a reasonable guess to begin with. Yeah, I think that would be a cool thing to talk about. Yep, very good idea. So take yourself, those of you who are in this video, take yourself out of it for a minute. Pretend you're watching any students and see what you're noticing about this conversation, okay?
I forgot my
Like flip.
flipping.
Yeah, so it's gotta be double, so it's 26.
I'm thinking it's 26, not 25. Because the 26 comes from him being
His own.
his own.
Yeah.
Yep.
But even this one, I have his own by red, wait, or whatever his is.
All right, so pretend it's not us. What do we notice about what's happening there?
They're all really smart.
Yes, that is so true. They're all really smart. You're exactly right. What else?
There's good disagreement.
Yes, good disagreement. Yeah, what else?
In some ways, each person had some kind of formula happening in their own head.
Yeah, but they were like hearing each other, right? They were grasping. It wasn't just like one person was talking and the other person wasn't taking anything in. They were like really listening to each other. So that can happen in your classroom, and it will happen in your classroom. But it has everything to do with you setting it up by choosing the right level of task. It worked, and it was like that because it was just the tiniest bit above what you knew how to do already. You know, that's what made it like so exciting. Imagine if you'd already knew it, if you already knew tree diagram, 5 times 5, I've got it. That conversation would have never happened. It didn't need to happen. Solved it. And imagine if it was like completely unapproachable. I have no idea how to do this. You'd just all be like, you know, so it was in that sweet spot, and you can do the same in your classroom. And I just want to reiterate that you're using this before they exactly know how to do it. You know, if I had already taught tree diagrams to you and I put this in front of you, it's only that exciting, right? And there's like not that opportunity for disagreement. So it's before you need it. I was telling Lori about this metaphor of like, I gave you the headache, and then the aspirin that you need for the headache is the math that you need to learn, the word tree diagram, how a tree diagram works, or just combinations in general. I don't want you to just think that the tree diagram is the only way to solve this, because we know we have this multiplying idea now too. Okay, I'll jump off my high horse there. All right, so I'm going to do a quick, hopefully, yeah. What time? We have 3:10? Ay, ay, ay. Okay, that's all right. Our conversations are important. A quick flyby of what's in each of the tasks, what's in each of the acts, but I want you to know that also in the calendar event, I put a link to this website where I have explained it like 3 different ways. So one where I tell you exactly what happens in that act, I give you an example, and then further down on this website, there's like a typed out place to look. So there's lots of ways. If you don't want to record anything right now, you've got plenty of ways that you can come back and look at it. Okay, so quick flyby. Act 1 starts with some kind of media interesting hook. That's what you can, sometimes it's a picture, sometimes it's a movie. It could even be something in your classroom, like an event that happens, and then we have to do an investigation. Hannah kind of did like a big array, right? Like the dice, because I mean, that was physically in front of them. It's still the same kind of thing. Then we want to notice and wonder about it. Could be typing their answers, could be just verbally saying them. Notice and wonder. Out of their wonders, you want to choose one of their questions to investigate. You already know which one you want to investigate. You've got one ready to go, and everything's headed in that direction. But you know, somebody says, "I wonder how many outfits there are." Fantastic question. Let's investigate that. You know, you're kind of like making them think that you're using their question when you are. Then we do that estimate idea usually, and that part about estimate how many you think it is, and then make a brave low guess and a brave high guess. That's a part of it. It's a really great idea to have them on their own put their brave low and their brave high on a number line, and then ask them to place their actual estimate where it really makes sense. So if they say like 10 and 50, that's for this one, and then their guess is I actually think it's 20. Does it go right in the middle, or does it go closer to 10, or does it go closer to 50? There's an opportunity to have some number sense right there. So that's in Act 1. Act 2 then is, okay, that's the question we're going to solve. We have an estimate. What do we need to do to figure it out to get it exactly right? And in order to figure out the exact answer. And the point of that is that that's what happens in real life. In a real life, you're not handed all the pieces of information when you're trying to solve a mathematical problem, like a building problem or a shopping problem. You have to think, oh, I need to know this, and I need to know this, and I need to know this. You want them to build that, what do I need to know in order to figure it out? So then you reveal info. Sometimes it's the information that they needed, and sometimes it's something different, and they have to attack it a different way. But what's cool about that is that what they ask for reveals something about how they think they're going to solve it. You know, it's giving you some ideas about what their strategies might be. And so the reveal was just that picture with the 5 people, okay? Then it's really important, we didn't really have this in here, but it's really important that we have some silent work time where they have to work by themselves. And then after a couple of minutes, 5-ish, however, you're going to watch them, then they group together and work together. Why would we want to have some silent work time by themselves? So they won't steal the smartest kid's answer. That's one reason. Why else?
You could get different, unique strategies that you might not get if they're working with a partner who is, what's the word, opinionated.
Yeah, you're going to get unique strategies. Like, if we had all started working together, then Teresa and Lori would have not started on 2 different things, right? They were, whoever was more like, woo, I got it, we would have gone with just that way.
We would have gone with the other because I'm wishy-washy.
So we would have only had the tree diagram and not a list of combinations. But we needed both of those to make the connection. So you need to give them an opportunity to work independently and then together. And then from there, you want to make sure that you have an extension ready to go, because there's going to be that kid that has solved it in like 7 seconds. In this one, an obvious one would be how many total combinations on this thing, right? Not just Zoolander, but all together. And how are we going to know that? How can we model that? That kind of thing. Or how would it change if there was one more, like one more side to this? And then that could get at your question of how could we always know the answer to it? Okay. Then this is really important. It's teacher-selected sharing when you get to Act 3. It's not who wants to share, and then you get like probably that kid who feels most confident is going to share. If you let them choose on their own, and then that might be most complicated, that kind of thing. You select and order who you want to share in what kind of order, and you've been walking around during their group time thinking about, who am I going to pick? I'm going to pick first the kid who used manipulatives. That's why I picked Van first, because he had picked manipulatives to use. And then I picked, one that was a unique strategy, because I really had a question about your 12 times 2 plus 1. I didn't know where that came from. And then we had the one that I was kind of thinking we were headed towards, which is a tree diagram. So I kind of had this storyline going and then trying to make those comparisons or connections. Make the connections between them. Then we do the final reveal. That's where I showed you the video of them counting down. And then we need to discuss discrepancies. Sometimes the reveal won't be the exact answer that they calculated. And you have to talk about why, what caused that. Not just a mistake, but like real life things cause something to be off just a little bit. Okay, I chatted a whole lot. What do you want to know before I show you the resources?
Did you put the number line for the estimate, the high and low? Did you add that question into this 3-act task, or was it just already in there?
So her question was about the 3-act task and the number line in Desmos. So I used someone else's template, and they built all the framework for it, and then I just dropped my video in there and a little bit of like my language in there, but it was already made inside Desmos.
Well, I was just wondering, because I used that other one on Desmos and I loved it, but I was wondering if I could add in
Yes.
where they could, okay.
Yes, we can add that. And what's cool about Desmos is like you find something you like on somebody else's, you can copy and paste it right into your activity. Yes, good question. Anybody else? Okay, so I'm just going to, where can we find? Let me just show you the resources. I think that's probably the most helpful thing. And then please ask me if you want to know more about any parts of it. This is the site that I did. Can anybody confirm that it's actually linked in?
I pulled it up.
Okay, great. Okay, so this is a site that I put together for 5th grade teachers about practical problems, but the 7th section of it is about 3-act task and numberless word problems. So if you scroll down to the bottom, after numberless word problems, then again, all I just explained about the acts are here. And then like with an example with the Krispy Kreme one. And then here's some really important resources. The guy who made it, you can watch him do one. He's super awesome here at those. This is probably, these are places to get elementary 3-act tasks. There are plenty of high school ones, but these are all elementary pretty much right here. And I've taken some time this fall to sort them by SOL. So if you go in here, you can search by your particular SOL. Even also go up and down on the same strand, and you can find some great things. And then some great ways to, like if you don't want to have them do it on the computer, these are 2 recording sheets here. Gotta go. Okay. I will stay for 5 more minutes if you have questions, but thank you, everybody.
Thank you so much.
Woo! It was a marathon.